Welcome, everyone. Today, we're exploring one of the most powerful extensibility features in Claude Code, hooks. If you want to ensure absolute, deterministic control over your AI's actions automating tasks before or after the AI executes code, this session is for you. Let's get started. Let's start by defining what hooks are in the context of Claude Code. What are they? They are user-defined commands or scripts that execute automatically at specific lifecycle points. The basics are simple. They intercept the AI's actions to run your logic. Why do we need them? If you put a rule in your Claude.md file, you are relying on the LLM's probabilistic judgment to follow it. But enterprise workflows require guarantees. Hooks provide that absolute, deterministic control. How do they work? You configure them in a JSON settings file. In our deep dive, we see that hooks are the bridge between AI autonomy and strict enterprise governance. They ensure that your required safety checks or formatting rules run every single time, completely removing the element of chance from your automated coding pipeline. Take a look at this flowchart, which illustrates the difference between standard instructions and hooks. When the Claude Code agent makes an action decision, it can follow two paths. The top path relies on Claude.md instructions, which are probabilistic, meaning the AI may or may not follow the rule perfectly. The bottom path, highlighted in blue, uses the hooks framework. This path guarantees deterministic behavior, leading to the green node. The script always executes. This visualizes why hooks are essential for strict compliance. Now that we know what hooks are, let's discuss when they fire. We call these lifecycle events. The basics are that events cover the entire session, from start to finish. When do we use them? The most powerful and common events wrap the AI's tool execution. Pre-tool use fires right before Claude runs a command or edits a file, and post-tool use fires immediately after. But it doesn't stop there. You can also trigger hooks on user prompt submit to validate user input or permission request to auto-approve dialogues. For our deep dive, understanding the timing is everything. Because pre-tool use fires before the action occurs, it has the power to block the execution entirely. This makes it your primary weapon for building impenetrable security gates and validation checks around the AI. This state diagram maps the lifecycle of a typical Claude Code turn. It begins with user prompt submit, where you can intercept the prompt. It moves to LLM processing and then hits the critical pre-tool use state. Here, the hook acts as a gatekeeper. If the hook allows it, we proceed to tool execution. If the hook blocks it, we instantly loop back to the LLM so it can correct its mistake. After execution, we hit post-tool use, and finally the stop event when the AI finishes its turn. Let's get practical. How do you configure your first hook? Hooks are defined using JSON, typically inside your projects.claude/settings.json file. The basics require a specific nested structure. You start with the hooks object, then the event name, then a matcher, and finally your handler. Why do we need matchers? Imagine a pre-tool use hook. If you didn't have a matcher, your script would run for every single tool Claude uses: reading, writing, searching. Matchers act as a filter, ensuring your script only runs for the bash tool or the edit tool. How do you implement the handler? You specify the type as command and provide your shell script path. In our deep dive, an important performance note: Claude Code runs all matching hooks in parallel. This concurrent execution ensures that your automated validations don't create massive bottlenecks in your workflow. This mind map breaks down the anatomy of a hook configuration. From the center, you must branch out and define three things. First, the event type, deciding if you are acting before a tool, after a tool, or at session start. Next, the matcher filter, restricting the hook to specific tools like bash or edit. Finally, the handler type, defining whether you are executing a local shell command, hitting a remote HTTP endpoint, or triggering an LLM prompt evaluation. To truly master hooks, we must understand the underlying communication model. How do Claude Code and your custom script actually talk to each other? The basics. When an event fires, Claude packages all the context into a JSON payload and pipes it directly into your script's standard input, or STIN. Why use STIN? Because it is a universal standard. It means you can write your hooks in Bash, Python, Node.js, or whatever language you prefer. How does your script talk back? Through exit codes. If your script exits with a 0, Claude allows the action to proceed. If your script exits with a 2, Claude blocks the action immediately. Our deep dive reveals a brilliant design feature. When you exit with code 2 to block an action, any text you print to standard error is fed directly back to the AI. Claude reads this error, understands why it was blocked, and autonomously corrects its approach. This sequence diagram maps the exact communication flow. Claude Code initiates the interaction by passing JSON context via SDDN to your script. Your script parses this JSON and runs its logic. If validation passes, the script exits with code 0, and Claude happily executes the action. But if validation fails, the script exits with code 2 and outputs feedback via stare. Claude immediately blocks the action and reads your feedback to adjust its next move. Let's put this into practice by building a pre-tool use blocker. What we are creating is an automated safety net that blocks dangerous shell commands before Claude can execute them. The basics involve setting up a pre-tool use hook, specifically targeting the bash tool matcher. Let's look at the sample code on the slide. This is a simple bash script. First, input equals $cat reads the JSON payload from Claude via stin. Next, we use the JQ utility to parse that JSON and extract the exact command Claude is trying to run. The script then uses an if statement to check if the command contains a dangerous pattern, like rmrf. If it does, we echo an error message to standard error and exit with code 2. This instantly blocks the action. If the command is safe, we exit with code 0, and Claude proceeds. This is a perfect example of deterministic enterprise safety. Let's trace the logic of our blocker script through this flowchart. When the pre-tool use event fires for the bash tool, our script reads SDDN. It parses the JSON using JQ to isolate the command string. We hit the decision node. Does the command contain rmrf? If yes, we take the red path, echoing to stare and executing exit 2, which guarantees the AI is stopped. If no, we take the green path, exit 0, and the workflow continues safely. Scripting is powerful, but what if your role requires human-like judgment? Welcome to advanced automation using prompt and agent hooks. What are these? They move beyond rigid shell scripts by using an LLM to evaluate complex conditions. The basics: a prompt hook sends the event data along with your custom instructions to a fast Claude model. Why do we need this? Because some rules, like checking if unit tests cover the right edge cases, can't be validated with a simple regex. How does it work? You set the hook type to prompt and provide your prompt string. The evaluating LLM analyzes the situation and must return a strict JSON object with an OK boolean. If OK is false, it returns a reason, which is used to block the main agent. In our deep dive, agent hooks take this even further. An agent hook actually spawns an entire subagent that can use tools to search your codebase and run diagnostics before deciding whether to block or allow the action. This architecture diagram contrasts our three primary hook types. When an event fires, the routing depends on the hook type. We already covered the top path, command hooks running local shell scripts and returning exit codes. But look at the bottom two paths. Prompt hooks use fast LLM evaluation, and agent hooks spawn a subagent with tools. Both of these AI-driven hooks converge to return a strict JSON payload dictating whether the action is OK, bringing intelligent evaluation directly into the control flow. Let's explore a real-time use case that drastically improves developer productivity, auto-formatting, and notifications. The scenario: a developer wants to guarantee that any code Claude writes is perfectly formatted, and they want to know when Claude is done without staring at the terminal. Here is the dual implementation. First, we set up a post-tool use hook with an edit-write matcher. After Claude edits a file, our script extracts the file path using JQ and silently runs prettier, auto-formatting the file perfectly. Second, we configure a notification hook triggered by the idle prompt matcher. When Claude finishes its work and waits for input, this hook runs an OS command to pop up a desktop alert. The entire workflow is seamless. Claude edits the file, the hook formats it instantly, Claude finishes, and your desktop pings you. The immense value here is that you maintain a pristine, compliant code base automatically while reclaiming your attention span. Watch the automation flow in this sequence diagram. Claude Code modifies a file using the edit tool. This immediately triggers the post-tool use event, sending data to hook 1, which runs prettier in the background. Once all tasks are complete and Claude becomes idle, it triggers the notification event. This data hits hook 2, which reaches out to the developer desktop and pings an alert. Zero manual intervention required from start to finish. Let's conclude with best practices and scope. Where you define your hooks matters. Define them in your projects.claude/settings.json to share them with your team via version control. Use your home directory settings for personal, machine-wide automation. You can even bundle hooks into plugins using a hooks.json file to distribute them globally. Having trouble? Always use the /hooks/ command inside your session to browse and verify your active configurations. Finally, remember to use the async true flag for long-running background tasks, like logging, so your hooks don't needlessly slow down Claude's response time. In conclusion, hooks are the ultimate mechanism for enforcing rules and automating repetitive workflows in agentic environments. Master them, and your AI pipelines will be unstoppable. I invite learners to subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you. Our final mind map summarizes hook best practices. From the core, we branch into scope, reminding you to intentionally choose project, user, or plugin levels. We branch into performance, highlighting the importance of the async flag and using narrow matchers to avoid running scripts unnecessarily. Finally, debugging relies on the powerful /hooks command, monitoring your exit codes, and utilizing stare feedback to keep Claude informed. Master this framework, and your workflows will be flawless.